හරි බලන්නද? අද අපිට දෙවෙනි පේපර් එකේ ඩිස්කෂන් එක තියෙන්නේ. පාඩ ඇප්ලයිඩ් පේපර් එකක් තියෙන්නේ. ඒක ඉස්සෙල්ලා මම පාර්ට් 2 ගණන් ටිකට ඉක්මනට යන්නම්. පාර්ට් A question number 2. Question number 2. Do with me. Here projectile question, initial velocity u, take this angle alpha, u given 2gr root, here projectile. A particle is projected from a point on horizontal ground at angle alpha to the horizontal with initial speed u equal 2gr whole thing root. R horizontal range. Show that the angle between two possible initial direction and projection pi/3. Okay. Now we know in projectiles we have two possible directions, same angle alpha to the horizontal, to the vertical, same velocity u, that represent same horizontal displacement. Now use s equal ut plus half at square. AB motion, first vertically, then u sin alpha, displacement 0, u sin alpha, capital T, take time of flight, t equals capital T, here t equals 0, minus g divided by 2 t squared, cancel t value, t not equal to 0, therefore t equal 2u sin alpha divided by g. Here time of flight. Then horizontally S value r, u value u cos alpha t. Now substitute t, r equal u cos alpha, t value 2u sin alpha divided by g. Now simplify, rg equal u squared 2 sin alpha cos alpha sin 2 alpha, then u squared equal 2gr, rg 2gr sin 2 alpha, then sin 2 alpha equal half, then 2 alpha equal pi divided by 3, pi divided by 6. Therefore angle difference, take beta, when beta equal pi over 2 minus 2 alpha, then pi over 2 minus pi over 6, it is pi over 3. Complete. So in projectile, same horizontal displacement can be obtained with to the horizontal angle alpha, to the vertical angle alpha with same velocity. Okay. Complete that question. That is question number 2. Okay. Then question number 3. Question number 3. Here simple question. System of poly part. Here object A, B, object C, mass capital M, here mass simple M, here mass simple M, do with me. Here tension T1, here tension T2, reaction R. The system is released from rest with string torque. Write down an equation sufficient to determine tension of the string, joining A and D. Okay, then need to use F equals MA. We know along a string, same acceleration. Along a string we have same acceleration. Therefore you take acceleration here F. Then use F equals MA. Capital A downward, mg minus T1 equal mf. Capital B downward, mg plus T1 minus T2 equal mf. Then capital M, object C, horizontally T2, capital M F. Now we have sufficient equation to determine tension. Okay, we have 3 equations, 3 unknowns, T1, T2 and F. You can find one. Write down sufficient equations to determine tension of the string. Then you can just write equations. Complete. Question number 4, work power energy question. A car of mass 1500 kg working with constant power 80 kilowatts moves on horizontal road against a constant resistance. Okay, question number 4. Here a car moves on horizontal track. Here 1000 capital M, 1500 kilograms. Power 880 kilowatts, then 80 times 1000 watts. Its acceleration given 2 meters per square seconds. Now its speed given v equal 20 meters per second. Then we have tractive force, we have resistance. We need to write sufficient equation. To determine acceleration of the car. Made the first okay, take this one P1R. Then use H equal PV. Then actually 80 times 10 to the power 3. Tractive force P1 acceleration A 2 meters per square seconds, v equal 20 meters per second, then velocity 20, then P1 equal 4000 Newton, then use F equals ma, P1 minus R equal 1500 acceleration A, then P1 4000, R 1500 times acceleration 2, then R equal 1000, now resistance 1000. Then next case, it moves along a track inclination alpha to the horizontal, alpha sine inverse 2/3, alpha sine inverse 2/3 with speed 8 meters per second. Here 8 meters per second. Same constant power and resistance same. Then tractive force can be changed. Take P2. Mark forces 1500 G, 10 Newton, reaction R. Take acceleration A. Acceleration not given. Now use H equals PV again. Then H value 80, 10 to the power 3, tractive force say P2. Now its velocity 8. Now you can find P2. You can find P2. Then use F equals ma. F equals ma. Then P2 minus R. P2 minus R minus 1500, 15,000 sine alpha. That's 1500 times A. Then you know P2, you know R, then you can find A. Then you can find A. Then we have sufficient equations. Okay, complete it. In work power energy theory කට්ටියට තාම කරලා නැති වුණාට මේක normally අපිට H equals P physics knowledge එකෙන් හදන්න පුළුවන්. H equals PV and F equals ma. That is question number 4. Then we have two instance. For two instance, same resistance. From the by the initial one, find resistance. Then by the second equation, then you can find acceleration. Use F equals ma and H equals PV only. Okay, then question number 6. A system of Polyg action again. System of Polyg action. Now the figure given like this. Then particle mass simple mg, mark reaction R, take tension T, mass 2 mg, inclination 30 to the horizontal. First we need to show that the magnitude of the acceleration of the particle is twice the magnitude of the acceleration of the movable pulley. Then need to show acceleration relation first. Then according by displacement relation, take here x, take here y, then x plus y, y 2y plus small part delta L, delta L, delta L equal L. Now differentiate. Differentiate with respect to time. Then x double dot 2y double dot 0. Here times twice. Therefore x double dot equal 2y double dot minus, then x double dot modulus equal 2y double dot modulus. Then acceleration relation we can obtain. Acceleration relation we can obtain. Then use F equals ma now. Now reach sufficient equation, no need to simplify. When use F equals ma, simple m along the surface, mg sin 30 minus t, mg sin 30 minus t equal ma. Acceleration, here you take f, now we upward f over 2, mf, then 2m is downward, upward 2t minus 2mg equal 2m f divided by 2. Here second equation. Second equation. Use F equals ma. Always here when you take acceleration f, here this will be upward f by 2. F by 2. Okay. Complete. That is system of Pulik action. Okay. Then question number 6. Question number 6, a vector question. Position vectors are given of A, B, C points. Then here, question number 6, here take O, A, minus 2p plus 5q, vector OA, then vector OB, OB 7p minus q, and vector OC p plus 3q. Now we need to show that ABC collinear. ABC collinear. So if it is collinear, you find AC vector. We need to find the ratio in which C divide AB. C divided by AB. Then take AC vector AO plus OC. Here minus 1, 2P minus 5Q. OC vector P plus 3Q. Then 3P minus 2Q. Then CB vector CO plus OB. Then minus P minus 3Q. OB vector 7P minus Q. Then 6P minus 4Q. Then you take 2 outside, 3P minus 2Q. Therefore now you can say CB vector equal, here 2 times AC vector, 2 times AC vector. Therefore CB parallel AC, since C is a common point, ABC collinear. ABC collinear. That's the condition. Therefore now the ratio CB vector modulus equal 2 times AC vector modulus. Therefore CB divided by AC to CB is to AC equal 2:1. Here division internally 2:1 ratio. 2:1 ratio. Simple question. Okay, then question number 7. Question number 7. Here rigid body question. Rigid body question. A rod stay like this with inclination pi over 6. A force to the vertical angle beta P, and there's a peg here, then perpendicular reaction R, so they meet at this point, then weight act like this W. A uniform rod, therefore 1:1 ratio. Here pi over 6, here pi over 3, pi over 3, here 90, here pi over 6. Beta, angle beta, here pi over 3. Okay? Then here reaction perpendicular to the rod. Reaction perpendicular to the rod. To the horizontal pi over 6, pi over 3, pi over 3, 90, then pi over 6, angle beta, beta. Now we need to find tan beta value. Tan beta value. We can consider equilibrium condition. Here you can apply Lami's theorem, or you can take moments, whatever it is okay, but I think here best method taking Cot theorem. Cot theorem. Need to find only angle, no? Angle relation, then ratio 1:1, 1 plus 1, here cot pi over 3, 1 plus 1 cot pi over 3 equal 1 cot beta minus 1 cot pi over 6. Then 2 cot 60, 1 over tan 60, 2 over root 3, cot beta, tan 30, cot 30, 1 over tan 30, root 3. Then cot beta value, over root 3 minus root 3 plus root 3, 5 over root 3. Then tan beta value, root 3 divided by 5. Root 3 divided by 5. Simple question. Okay, then question number 8. Question number 8, again equilibrium of a particle, here weight W, here to the horizontal pi over 3, then here pi over 3, here angle alpha, in this part pi minus alpha plus pi over 3. Then you can apply Lami's theorem. Just apply Lami's theorem, mark forces, here tension T1, tension T2. Then W over sine pi minus alpha plus pi over 3. T1 over, then here 90 plus alpha, sine pi over 2 plus alpha, T2 over sine pi over 3 plus pi over 2. Then W sine 180 minus means sine alpha plus pi over 3. Then T1 over cos alpha T2 over, here sine 90 plus mean cos pi over 3. Find the tension in the string AP. AP mean T2 value, subject T2, W cos pi over 3 over sine alpha plus pi over 3. Cos 60 sine 30 half, W over 2 sine alpha plus pi over 3. No need to simplify, yeah? This is it. Hence find minimum value of this tension and the corresponding value of alpha. Then alpha variable, no? So to find minimum value of T, then this denominator must be maximum. So this maximum value is 1. For sine, it is 1. Therefore, T2 minimum value occur when sine part 1, then minimum value W over 2, where sine alpha plus pi over 3 equal 1. Equal 1. Therefore, alpha plus pi over 3 equal pi over 2, then alpha equal pi over 6. Therefore, the minimum value of T2 obtained when alpha equal pi over 6. Pi over 6. Equilibrium condition, apply Lami's theorem, thereafter use trigonometry to analyze that relation. Complete. That is question number 8. Now let's go to question number 11. Question number 11. Question number 11 part A. A linear motion question. two particles moves on a linear path. The plane incline alpha to the horizontal case. Okay. Now see this. Now you consider a particle, then smooth reaction R, take acceleration F, given as mg alpha, use F equals ma, then mg sin alpha equal mf, therefore F value equal g sin alpha. Here acceleration, so the particle has acceleration downward g sin alpha. The particle P is given velocity u upward along the line of data slope to O. Here same point O. Here particle P, particle Q. Then particle P given a velocity u upward. I take positive direction upward, negative direction opposite. Then linear motion, here time axis, velocity axis, here positive direction first quadrant, negative direction fourth quadrant. Then here initial velocity u, it is like under gravity motion. Here it is motion of P with respect to earth. Then next particle Q start with velocity 0, moves downward. Then same acceleration, this one change, acceleration same. Therefore take this angle beta. Then tan beta given F, that is F sin G sin alpha. Here object Q. Assume that two particles do not leave the inclined plane, sketch VT graph of the motion P and Q on the same diagram. Using the graph, show that at the instant where the particle P returns to the point O. Okay. Now here take time t. So we know property, when it comes to the initial position, it takes same time duration. Then here t, this will be 2t. Then after that you sketch second graph. Then tan beta value g sin alpha equal u divided by t, u over t. Then t value equal u over g sin alpha. Here this t value u over g sin alpha. Then it goes same displacement again, it comes back to O, then same time t. The particle Q is at distance, then displacement of Q. Then particle Q start from here, it goes along the path. Therefore its displacement given by this full area. Okay. Therefore displacement of Q, take this full area, take here value minus V. Then half into 2t into V. Then TV will be the displacement. We know T now, u over g sin alpha. T value u over g sin alpha. Need to find V now. Then again tan beta equal V divided by 2t. Here V divided by 2t. Tan beta means g sin alpha. Therefore V equal 2t g sin alpha. Simplify, t value u over g sin alpha. And that is 2u. Then you put V equal to u. Then finally you 2u squared over g sin alpha, displacement from O. Displacement of Q from O. Simple question. we have two particles with different directions, especially opposite directions. Here positive direction, first quadrant, negative direction, fourth quadrant. Then each particle, whatever it is, whatever the mass, its acceleration won't change, that is T sin alpha. Because smooth නැති වුණත් ඒක කතාව වෙනස් වෙනවා. Okay, complete. Smooth surface, we can consider acceleration as G component, G sin alpha. Likewise, you can resolve acceleration, gravitational acceleration. But if it has a friction, then we can't do so. Complete. Okay, then relative velocity part. ABC 3 lamp posts lie in a horizontal plane at verses of an equilateral triangle of side simple A. Wind blows in the direction AC, steady speed U. Relative velocity correction. Here triangle ABC, wind velocity given along AC. When you take AC horizontal, A, here B, C, here velocity U. Then velocity of wind with respect to the earth, U given. A bird whose speed relative to wind V, velocity of bird with respect to earth, V given greater than U. Flies from A to B along AB and B to C along BC. Then velocity of bird with respect to earth, here with respect to wind. A bird whose speed relative to the wind V. Now here path, here earth points now. Then directions with respect to the earth. Here 60 degree, equilateral triangle 60, 60, then 60. Ensure the total time taken for the journey from A to C. A to C from B. Okay, now write relative velocity theorem. Then velocity of bird with respect to earth. Here we have three vectors. One contain magnitude, direction both. The other contain only magnitude, the other contain only direction. Then you subject direction on quantity first. Subject this one. Then here B, D, W, V, W, E. Then bird, we have two cases. Here V, here U. U won't change. Here velocity of wind won't change. Then take this vector PQ, then this vector QR, then resultant must be PR. PQ won't change for two cases, but R will be changed. Therefore take Rx, X we say 1 and 2. We have two cases now. Then here PR1, then here PR2. Okay. Then sketch PQ vector, velocity U, QR magnitude V, then Q, V value greater than U. Then from Q find possible R point. That's on a circle. Here Q center, V radius circle. Then PR1, PR1 to the horizontal 60. Then PR2 to the horizontal 60 again. Here 60. Now completes velocity triangle. Here QR2, that is V, QR mean V. These two are same. Resultant PR. Take A, take B, B. Okay, now you find B. Then best method, sketch perpendicular line to this. Then U sin 60 here, U sin 60 equal root 3 U over 2. Here U cos 60, this part U cos 60. Here U sin 60, U cos 60. U cos 60, U over 2. U over 2. Now apply Pythagorean theorem for this part. Then I take B for this. Then B equal, here V square minus root 3U over 2 square root. Here 4V square minus 3U square divided by 2 root. Therefore PR2 equal B plus U over 2. Here B plus U over 2. Then by the Pythagorean theorem find B, V square minus root 3 over 2 square. Then add U over 2 part. Then you can find PR1, similar PR2 same. Then PR2, PR1 both same. Then B value 4V square minus 3U square over 2 root U over 2. Then PR1 equal PR2. Then it motion along AB and BC, displacements given A. Therefore total time A divided by PR1 plus A divided by PR2. A divided by PR1 and PR2. Now simplify this. PR1, PR2 same. 2A times 2A divided by PR. Here 2A. 4V square minus 3U squared root plus U over 2 over 2. Then simplify 4A 4V square minus 3U squared plus U. That is it. That is question number 11, part B. Okay, now then let's move to question number 12, part A and B. 12 part A, relative acceleration question. Simple question, particle simple limb, slide down smooth face of inclination alpha to the horizontal of a wedge of mass capital limb, wedge free to move along smooth horizontal table. Usual general question. Question number 12, part A. Here horizontal surface, here the wedge alpha, capital MG, R, simple MG, mark all forces, R1, then take acceleration F ma. Then acceleration of simple limb, capital N, with respect to the earth, a horizontally, acceleration of simple limb with respect to earth, addition of these two, here a, alpha f. Then use f equals ma, consider for system, horizontally no force, then 0, we have two objects, capital M and simple M, m times acceleration a, simple M times its acceleration get by here, a minus f cos alpha, okay. Then consider simple M along the surface, you always use f equals ma along the surface, because we can neglect reaction, then only we can neglect reaction. Therefore, mg sin alpha equal m times acceleration f minus a cos alpha, Now we have two equations, the first equation, second equation. Now we can simplify, better to remove f, therefore 1 plus 2 into take cos alpha, then you can cancel f, 2 into cos alpha, then mg sin alpha cos alpha, equal, here mf cos alpha you can cancel, capital M A, simple M A, minus ma cos square alpha will be there, capital M plus simple M minus simple M cos square alpha a. Now you know for this part m 1 minus cos squared alpha, then m sin squared alpha. Therefore a value mg sin alpha cos alpha divided by m plus m sin squared alpha. That is a value. But we need reaction between particle and wedge. Then to find this reaction, definitely use f equals ma. Don't consider equilibrium conditions. Okay. To find reactions, always use f equals ma. Otherwise, it is wrong. Then R1 minus mg cos alpha equal m, its acceleration. Here perpendicular line, this is alpha, here to the perpendicular, here a sin alpha, opposite direction, minus a sin alpha. Then reaction R1 equal mg cos alpha minus ma sin alpha. Here the reaction. We just find the reaction. No? Then mg cos alpha minus ma mg sin alpha cos alpha over m plus m sin square alpha sin alpha. Now we can take common denominator and simplify it. Before that, better take common terms outside. Mg cos alpha take outside. Here capital M plus simple M sin squared alpha. Here mg cos alpha. Take mg cos alpha, then simple M sin square alpha will be there. M plus m sin squared alpha. Okay. Then capital M simple M g cos alpha divided by m plus m sin squared alpha. Okay. That is the reaction. Complete. Check your answers. Okay, then part B question, circular motion. Part B, here a tube, displacement A, then here circular part, quarter circle, OD, here radius A. The particle, here initial velocity you given 5 h root, 5 h root, particle mass simple length, okay. Now further it says that another particle q of mass m is placed inside the tube at the point A. Here A, B, C. Projected velocity 5 h root in the direction AB. The coefficient of friction between the particle Q and the section AB here friction, there's friction, mark force mg, reaction R, here friction F, then F equal mu R, then vertical forces R equal mg, F equals mu R, then mu equal half mg. BCD part smooth, this part smooth. Take this velocity V, use F equals ma, find its acceleration, then minus F equal m acceleration, say F. The acceleration this portion simple F, then F equals half mg, mf. Then we have retardation F equal minus g over 2. We have retardation minus g over 2. Then find this velocity. Use v square equal u square minus 2as equation. Then velocity v. Initial velocity u square 5 h to acceleration 1 over 2 minus g over 2. G over 2 S mean A. Simplify. Then here 4ag root V equal square root 4ag. Here at B velocity 4ag, at C also same velocity V because smooth, no? Smooth. Okay. Now the after circular motion part, show that the speed of V of the particle R when OR particle connect when the particle Q moves through the tube and collides another particle P. Okay. Then connect then here velocity V, mass simple length, particle simple length, मतलब P के mass से दीला नहीं ना, P के mass से दीला ना एक m के लगाना, mass of the particle P simple length. Okay. Now here 2m, take velocity v1, then conservation of momentum mv, 2m v1, then v1 equal v over 2. V equal 4ag root divided by 2, it is ag root. Here starting velocity ag root v1. එතකොට ඔය p කියන පාටිකල් එක මේ අතරමැද කොහේ හැප්පුණත් ඕක හැමෝම තමයි. මේ ටික ස්මූත් නේ. මේ ටික velocity වෙනසක් නැහැ. කොහේ හරි තැනක හැප්පුණත් එකමයි. Okay, then circular motion part. Circular motion. So for the after circular motion, here it turn angle theta. It turn angle theta with the downward vertical. Now take here velocity v1, v2. Then mark forces r1, 2 mg now. I take V0 level here. Now use conservation of energy. Here half dash 2m initial velocity v1. Then half 2m here velocity v2. 2m g its height. Height here a minus a cos theta. A minus a cos theta. For circular motion, use conservation of energy and towards center f equals ma. That's it. Here radius a, here radius a cos theta, then a minus a cos theta. Height. Now simplify. Cancel 2m, cancel 2m, 2m. Multiply by 2. v1 square, v2 square plus 2ag 1 minus cos theta. We know v1, it is ag, v2 square 2ag cos theta. Then v2 square, take ag outside, 2 cos theta minus 1. 2 cos theta minus 1. v2 square 2 cos theta minus 1. Then find the reaction on the particle rod from the tube when it comes to instantaneous rest inside the tube. Okay. Then use F equals ma. F equals ma towards the center. Then here R1 minus 2mg cos theta. 2m radial acceleration v squared over radius a. Here v2 squared. Then r1 equal 2mg cos theta plus 2m over a v2 squared. Here ag 2 cos theta minus 1. Then simplify 2mg 3 cos theta minus 1. So need to find R when it comes to instantaneous rest. Instantaneous rest. Okay, see what is that? Okay, when it comes to instantaneous rest mean, here this velocity general one. Theta angle එක කරාම general velocity එකක් ආවා. ඒක 0 කරන්න. When v2 equals 0, it comes to instantaneous rest. Then ag 2 cos theta minus 1 0. Then cos theta equal half. Therefore r1 equal 2mg 3 cos theta half minus 1. 3 over 2 minus 1 1 over 2. Then reaction mg. Reaction mg, simple question. Always circular motion, relative acceleration, sure simple questions. That is question number 12. Okay. Then question number 14. Question number 14, part A vector question, part B coplanar forces question. Here given ABCD is a trapezium. ABCD is a trapezium. DC half of AB. Here AB, CD. DC vector half of AB vector. Here AB vector P, then half P vector. Then AD vector Q, here vector Q. The point E lies on BC. Point E lies on BC, 1/3 BC. Here point E. Then BE equal 1/3 BC. Then ratio 1:2 ratio. The point of intersection F of AE and BD. BD and AE. Meet at F. BF lambda times BD. BF lambda times BD. Show that AE vector. Here AE vector AB plus BE. AB vector P. BE vector 1/3 BC. Here vector P. Here 1/2 vector P. Then vector P 1/3 BC. BC equal minus P plus Q plus half P. Minus P plus Q plus half P. Now simplify. You take common denominator 6P minus P 5P plus 2Q over 6. Then separate denominator 5 over 6P 1 over 3Q. 1 over 3Q. Then AF vector AF equal AB plus BF. AB plus BF. Triangle of vector addition. AF equal AB plus BF. Then AB vector P, BF vector given lambda times BD. Lambda times BD. Then vector P lambda times BD vector. BD equal minus P plus Q. Plus Q. Then 1 minus lambda P plus lambda Q. 1 minus lambda P plus lambda Q. Hence find the value of lambda. Lambda hoyan. Then here AF no? AF. Further you get, let AF equal mu times AE. मैं line में कहती है that on the line AE. AB equal mu times, AF equal mu times AE. AF equal mu times AE. Then mu times AE vector on here 5 over 6 1/3 Q. Therefore now equate these two. Here 1 and 2. Same vector, different method. Then 1 minus lambda P lambda Q mu 5 over 6P 1/3 Q. Now take all terms into one side, multiply by 6 first. 6 1 minus lambda P 6 lambda Q 5 mu P 2 mu q. Then 6 minus 6 lambda minus 5 mu p. 6 lambda minus 2 mu q null. එතන 0 දැම්මේ ය ලකුණු අඩු වෙන්න ඕනර ඒක null වෙන්න ඕන null vector. Now separately equate coefficients to 0. Therefore this part 6 minus 2 mu 0, 6 lambda minus, therefore mu equal to 3 lambda. Here 6 minus 6 lambda 5 mu 0. Take here 1. Then put mu equal 3 lambda. Then 6 minus 6 lambda 5 mu. Mu equal 3 lambda. Here lambda equal 6 divided by 21. 3 over 7. Over 7. Lambda value 2 over 7. Hence find the value of lambda 2 over 7. That is question number 14, part A. Okay, then 14 part B. Coplanar forces question. Coplanar forces question. Okay, check it. Now, a regular hexagon given. Here, regular hexagon. We know inclinations 60 degrees to the horizontal. Here say A, B, C, D, E, F. AB vector along AB, unit vector I, AE, unit vector J. Then ABP, CD 7P, CD 8P, ED 7P, FE 3P. Then here 60 degree, 60 degree inclinations. We have 1, 2, 3, 4, 5 forces. Okay, now take in ij unit vectors along AB and AE, express each force in the form I, J and P. That means need to resolve it. Then here AB vector P, here is on you write PI, we have only I component. Here 7P cos 60, 7P sin 60, minus 7P cos 60, minus ni mere patta direct in 7P cos 60I minus 7P sin 60J, better to simplify, minus 7P over 2I, 7 root 3P over 2J. And here 8P cos 60 minus 8P sin 60 plus, minus 8P cos 60I, 8P sin 60J, IJ format. Here cos 60 half minus 4P I, 4 root 3P J. Then here 7P I, then here 3P cos 60I plus 3P sin 60J, 3P over 2I, 3 root 3P over 2J. That's it. Show that the given system equivalent to a single force of R. Need to find R vector. Then R vector then known. Then resultant vector, take algebraic sum Pi by plus minus 7P over 2I plus minus 7 root 3 over 2J plus minus 4Pi 4 root 3Pj plus 7Pi plus 3P over 2I 3 root 3P over 2J. Now take I terms, J terms together and add them. Here 7P, 3P, 4P. Minus 7, minus 4 over 2, minus 2P. I. When you just write 2P. Then here 7 root 3 minus 4 root 3, 2 root 3 minus, then in this one 2 root 3 P J. Now you take common 2P outside, I plus root 3j. That is the resultant vector. Vector sum එක විතරක් ගත්තා නම් හරියි. Take only vector sum. Show that this is parallel to BC. Here horizontal component 2p, vertical component 2 root 3p. Angle alpha, tan alpha 2 root 3p over 2p, alpha pi divided by 3, therefore R parallel to BC. R parallel to BC. Then what is the magnitude of R? R vector magnitude. Here 2p square x square plus y square root 2 root 3p square root 2p times 2 4p. Here 4p is the resultant magnitude. Simple question. Okay, now next, show further that the line of action of the resultant passes through the common point of DE and AF. Here DE and AF. Take this common point, take capital H. Take this common point, capital H. Then if the moment capital H 0, then we say resultant passing through H. Then take moment about H. Find GH. So you're going to find moment about H. Forget 7p. You have 3p, p, 7p, 8p. Now P into perpendicular distance. Here sketch perpendicular. Here A, then here 2A, angle 60, 2A, sine 60. P into 2A sine 60. Then take 3P. Here same. 3P into here sketch perpendicular. Here 60, no? A sine 60 again. A sine 60. A sine 60. Then forget 7P. 8P sketch perpendicular. Here 60, 2A sine 60. Then 8P into then here 7P. Then perpendicular distance A sine 60, A sine 60, A sine 60, 3A sine 60. Then minus 7P into 3A sine 60. Moment equal force into perpendicular distance. Then here plus 8P plus, here 7P minus. Now you simplify. Take PA sine 60, PA sine 60, here 2 plus 3, 16, 21. 16, 5, 21, 0. 0. Therefore, resultant passing through H. H means common point of ED and AF. How common point of ED and AB. Okay, then further given, if the system is equivalent to a force R acting through the vertex A together with the couple. Now up to now the system now equal to this. Now resultant passing through this point, here A, B, C, D, E, F, here H. Resultant here capital R, here 60-degree inclination. Now given that equivalent to a single force together with couple, we know single force equal to single force plus couple. Single force equals single force plus couple. Now the resultant you put here capital A, no? Put same direction R and couple, take G. Okay. Then here resultant equal single force equals single force plus couple. Then converse, single force plus couple equals single force. Then now equal. Okay. Then take moment about A. Here system moment about A anticlockwise equal resultant moment about A anticlockwise. So if you take moment about A anticlockwise, here R times sketch perpendicular now. Make it perpendicular now. Now A 2A, here angle 60, 2A sine 60. Here minus. Moment here R G. By R we don't have any moment, then take only G. Then here couple magnitude G equal R value 4P. 2A sine 60 root 3 over 2. 4 root 3 PA. Here the couple. Single force equals single force plus couple. इधर මෙයාට equal වෙනවා. මේ RE දෙන්නම same direction same magnitude. අපිට එහෙම shift කරන්න නම් මේ වගේ couple එකක් add කරොත් මෙයා මෙතන shift වෙනවා. මේ දෙන්නම equal. හරිද? Okay, then let's move to question number 15, part A, friction question. A uniform rod AB, weight W, length 2A, kept in equilibrium with NA, contact with rough vertical wall. It is supported by light inextensible string of length 2A, same length string. Same length string. To the point B and point C on the wall. Okay. Now, question number 15. Here the wall, rough wall, here a rod, string connected. Here reaction are downward slipping tendency, here friction upward, weight W. Here the system now. System. The rod incline theta to the upward vertical. Here theta, then same length A. Here this will be AA. Angle theta. Mark tension T. W. Okay. Now there's inequality. Friction inequality mu greater than or equal F divided by R. You can have the condition. Then you find mu and F and R. Then first you take moment about A, here B, here C. Moment about A, W into here A, perpendicular distance A sin theta. Here W, here A sin theta. Here theta, 90 minus theta, 180 minus 2 theta angle. Then T cos 180 minus 2 theta goes to A, forget it. Then T sin 180 minus 2 theta, that is perpendicular to the rod, into 2A. Check it again. Here theta, 90 minus theta, all together 180 minus 2 theta. Then T cos 180 minus 2 theta passing through A, then when you take moment about A, you forget it. Then T sin 180 minus 2 theta will be perpendicular. Then perpendicular distance 2A, here is length 2A. Then simplify, cancel A, W sin theta, sin 180 minus 2 theta, sin 2 theta, W sin theta, T, 2 sin theta cos theta, answer sin theta T equal W over 2 cos theta. Here tension. Then resolve horizontally, R equal T cos theta, here T sin theta, no? W over 2 cos theta into sin theta, W over 2 tan theta. Then resolve vertically, T cos theta plus F equal W. So the system is in equilibrium. Consider vertical upward forces to vertical downward force. Then left hand force equal right hand force, both same, and moment 0. That's it. Now T mean W over 2 cos theta plus F equal W. Now F equal W divided by 2. Then the inequality, corresponding inequality, mu greater than or equal F divided by R. No need to put modulus sign. Usually mu greater than or equal F divided by R modulus. But here we know definitely that slip downward. Therefore friction upward, sure. Then no need to put modulus. Then continue. Mu value greater than or equal F mean W over 2 tan theta. Then Here cot theta mu over 2 mu කක්කරි තන මිස් එකක් තියෙනවා t plus f here another 2 4 sin theta then w divided by 4 cos theta w divided by 4 4 4 3w of 4 3w of 4 4 mu over 3 then get inequality theta change sign cot inverse mu divided by 3 cot කෙනෙකුට inverse ගන්නකොට sin එක මාරු කරන්න ඕනේ cos වලටත් එහෙමයි cot change inequality then theta inequality එක ඇවිල්ලා තියෙන්නේ complete සාමාන්‍ය with body questions ගොඩක් lazy ඔයාලා හරියට forces mark කරන්න තියෙන moment ගන්නයි resolve කරන්නයි විතරයි ඒක ගන්න පිළිවෙල තමයි හදා ගන්න ඕනේ කොතනින්ද පටන් ගන්න කියන එක යන්න ඕනේ path එක හදා ගන්න ඕනේ ගොඩක් moment එක කියන්නේ හොඳ operation එකක් unknowns අඩු කරන්න තියෙන. ඒතර මම මෙතන A ගේ moment එක ගන්නකොට මේ දෙන්නම අයින් කරනවා. T කියන එක just එනවා එකපාරට. 0 නෙවෙන්නේ. ඒතර එතනට ගියේ ඒකින්ද. ඔයාලා මෙතනින් මම ස්මාර්ට් ගියොත් මෙතන දෙන්නේ ඉතුරු වෙනවා. එහෙනම් ඒ වැඩේ හරියන්නේ නැහැ. ඒකම තමයි ඉස්සෙල්ලා start එක යන්න ඕනේ. A ගෙන් start එක අරගෙන තමයි ඉස්සරහට යන්නේ. Okay, then 15 part B framework boss notation එකෙන් ගන්න තියෙන boss notation දන්නේ නැති හින්දා මම වෙන මෙතඩ් එකකින් යන්න. ඒක මම කිව්වාට කැමති විදිහට ඒක හදුවට අවුලක් නැහැ කියලා. Okay. Now here system of light rods. 90 horizontal, 500 Newton, 60, 30, 30, 30. Then better to mark forces here, T1, T2. Consider this vertex C. Vertex C, vertical forces, T1 sin 30 equal 500, then T1 equal 1000. Then resolve horizontally, T1 cos 30 equal T2. T2. Then T2 500 root 3 Newton. Then here T2. Then mark here T3, T4. Then resolve T3, get vertex B, vertical forces T3 cos 30 equal T4 cos 60. T3 root 3, T3 equal T4. හරිද? light rod වල තියෙන stresses ටික නිකන් just mark කරගන්න. කොයි හරි direction දැම්මම ගමන්නේ minus આવත් ඒකට opposite දාගන්නයි තියෙන්නේ. හැබැයි මේකට අපි වෙනම technique එකක් තියෙනවා Gauss notation. ඒ technique එකක් තියෙනවා මේ week එකේ Gauss notation දවස් දෙකකින් කරනවානේ Gauss notation joint dose දෙකම. ඒතර මේ ඒ කතාව ඉවර කරගන්න පුළුවන් දන්නේ නැති කට්ටියට. හරි. Then resolve horizontally T3 cos 60 plus T4 cos 60 plus T2 T3 half T4 root 3 T3 half cos 30 ne. T2 500 root 3. Then here 3 over 2, 4 over 2, 2 T3. 500 root 3 Newton. Then T3 equal minus 250 root 3. Minus in opposite direction. Then T3 not a tension, that is a thrust. That is a thrust. Then T4 minus 250 root 3 times root 3. Then 750 Newton minus. Then this also opposite direction, not tension, that is thrust. Okay. Like Gauss notation නෙවෙයි. දන්නේ නැතිනම් තමයි මේ මෙතන දෙන්න කරේ. That is question number 15. Okay. Then question number 16. Question number 16, center of gravity question. Now then proof eකට යන්න question එකට යන්න. X axis, y axis, cylinder, a cone, need to cut. ABCD height capital H. Yes, height simple h. That is the object. Now, find distance of the center of gravity from AB. Then by symmetry, center of gravity lies on the x-axis. Therefore, y bar 0. Mass per unit volume, rho, object, mass center of gravity, object, cylinder, cone, remaining body. Here volume pi r square h. Here radius capital R, rho. Here 1/3 pi r squared h rho, then subtract pi r square h rho minus 1/3 pi r square h rho. Then here center of gravity h/2, here h by 4, here x bar. That's the table. Okay. Then take moment about y. Moment about y-axis, then multiply these two, subtract, that equal to this. Then pi r square h rho, 1/3 pi r square simple h rho x bar equal pi r square h rho h/2, 1/3 pi r square h rho h divided by 4. Now simplify that. Center of gravity එක හොයන හැටි යන්නේ මොමන්ට් එකේ. Now simplify. Pi r square rho common, cancel. Then h/3 x bar. Here h square over 2, h square over 12. Then 3h minus h over 3x bar, 6h square minus h square divided by 12. Then x bar, 6h square minus h square over 4, 3h minus h. Now here the center of gravity. Center of gravity. Hence show that if the center of gravity lies at E, then let x bar equal h now. Given that center of gravity at E, your point E. Therefore x bar equal h. Then you simplify. H equal 6h square minus h square 4, 3h minus h. Now solve it. Solve it. Then 12 h minus 4h square, 6h square minus h squared. Then need to find simple h. Take one side then 3h square minus 12h plus 6h square 0, quadratic equation, cancel 3, h square 4h 2h square 0, then h equal minus b plus or minus b square minus 4 a c root divide by 2 a. Simplify. Since h greater than 0, you take positive value, minus 4h, take plus value, cancel 1 4, 4 squared, 4 times 2 h square root over 2, and cancel 1 4, then minus 2h plus here 4 minus 2 root 2h. H greater than 0, less than capital H, then we need to select minus 1. Now 2 minus root 2h, 2 minus root 2h, complete. Then at the end it says that assuming that the center of gravity S lies at T, show that S will not topple. හරිද? topple වෙන්නේ නැහැ කියන condition එකක් ගන්න තියෙනවා. The angle alpha in contact with DC here center of gravity here, then mark weight, mark reaction, mark friction. හරිද? අපිට ඔය equilibrium එක කැඩෙන්න පුළුවන්, break වෙන්න පුළුවන් methods දෙකයි, slip and topple. slip and topple. slip වෙන්න නම් limiting එකට එන්න ඕනේ. F equals μr. topple වෙන්න center of gravity එක base එකෙන් එළියට ගන්න ඕනේ. එහෙම නැත්නම් මේ reaction එක base එකෙන් එළියට පයින්න ඕනේ. Then you take here this part, capital H minus simple h, take this part A. Alpha 90 minus alpha, 90 minus alpha, alpha, then tan alpha A over h minus h, h minus h. Then you find A value, find A, h minus h tan alpha. A less than r when on. A less than r, not to topple. May A value will exceed correct r can topple now, not to topple. Then A mean h minus h tan alpha less than r. In terms of capital H, simple h equal 2 minus root 2h, 2 minus root 2 capital H, tan alpha less than r. Here root 2 minus 1 h r divide by tan alpha cot. හරි ඒ පාර්ට් එක අපි එතනින් ඉවර කරමු. ඔයාලට ඒතකොට ඊළඟ දවසේ පේපර් එකක් ලියන්න තියෙනවා පියෝ පේපර් එකක්. ඒක රෙඩි වෙන්න. ඒ අතරේ හැමදාම වීක්ලි පාස් පේපර් එක ලියන වැඩේ නතර කරන්න එපා. ඒක ලියන්න කලින් ප්‍රශ්න කරලා තිබුණාට කමක් නැහැ. ප්‍රශ්න කරා කියන එක නෙවෙයි වැදගත්. ඔයාලා ෆුල් පේපර් එකක් ලියලා මේන්ටේන් කරන එක. ඒ හින්දා මේ ෆුල් පේපර් එක ටයිමින් කරලා පැය 3 විනාඩි 10 අරගෙන සම්පූර්ණ පේපර් එකක්ම කරන්න ගන්න. සතියේද සැරයක් අනිවාර්යයෙන්ම දිගට කරගෙන යන්න. හරි. අපි එහෙනම් එතන ඉවර කරමු නේ.